Hi, we are now closing Module 5, Impact of Renewables on Electricity Markets, with its fourth block, the impact of renewables from simulation to reality. We have been through various blocks where we understood what had an impact on electricity market, the role of renewables, what is the mechanics for this impact of renewables on market. Now we would like to extend that by simulating this impact over longer periods and actually using data from a real electricity market to appraise this impact in reality. So let's start with some simulation. We want to simulate the impact of wind power generation on the Nord Pool, and for that we use the reference year of 2011. All the supply curves and the demand curves can be obtained from the Nord Pool website. These are for an unconstrained system. We don't account for the potential limitation for transfer of energy from some areas to the next. This is the simple model that we have to obtain the system price. Eventually, we're going to shift around these supply curves, and our aim is to look at a future with more wind power generation in the system. So we are not going to lower the quantity of wind power in the system, we are only going to increase it. The various coefficients we're going to apply, for instance, is 1.2, so we multiply by 1.2 the wind power generation in the system, 1.4, etc., until 4. So we want to multiply by 4 the amount of wind power generation in the system. We have this supply and demand curve, these equilibrium points for which we have a price, the equilibrium price, and the volume that is cleared overall for the Nord Pool area. And we have this information for each and every market time unit over the year we want to simulate. Now we're going to move around these equilibrium points by changing the quantity of wind power generation in the system. This would be the series of prices that we obtain. Here in the x-axis, we have all the market time units from 1 to 8,760. Here in this axis, we have the prices in euros per megawatt hour. And these various curves that we see here, they are in black the reference curve, so the true system prices for each and every market time unit throughout this year. And the other curve in gray is as we increase wind power generation by some factor that is greater than 1. And in red is the eventual case where we multiply by 4 wind power generation in the system, and you can see that there is an impact. The price can drop quite a lot here when we look at the red curves. All these curves are on top of each other, so maybe it's a bit difficult to see, but I can tell you that if you zoom on this curve, you will see some periods with some dramatic effect of increasing wind power generation. Now, if we were to look at some statistics, we can look at the mean price throughout the year by increasing wind power generation, and we can look also at the minimum and maximum prices that were observed throughout the year. This will give you some indication of how dramatic the effect may be. In terms of the mean price, over this reference year, the price were actually fairly high, 48.15 euros per megawatt hour, and as we increased wind power generation, the average price is actually lowered by 15 euros approximately and reaching 32.82 euros per megawatt hour. Now looking at the minimum and maximum prices. In the reference year, the minimum price was above 0, and the maximum price is out of the chart. It actually reached very high level, almost the roof you can have in the market in Scandinavia. As you increase wind power generation in the system, the minimum price is going below 0, since you're going to have too much wind power generation at some time, and then you're going to have a negative price. And then the maximum price is also dropping dramatically. We will never see prices above 100 euro if everything else stay the same and we have a lot more wind power generation in the system. This kind of study on future prices in electricity markets and the impact of some drivers are very important, for instance, if you would like to invest in new capacities. You would like to know what is going to be the price in 5 years, in 10 years, how is this going to develop, how is this going to be sensitive to various type of events or developments. So these kind of studies are extremely important, and we can play with this supply and demand curve, their equilibrium, and change a few parameters. Now let's go from simulation to reality. For that, we can collect all the data in the Nord Pool. You can collect data about wind power, solar power, the demand, the prices, etc. And then you can look at their relationship and eventually apply some regression technique to infer on the relationship between certain input variable and the price. So this is what was done here by Trygve Jonsson and co-authors. They collected data in 2007 for the Nord Pool, the Western Denmark area DK1, and Trygve Jonsson and co-authors looked at the impact of the forecasted wind power penetration on prices. By forecasted wind power penetration is meant the ratio between forecasted wind power generation and forecasted load. The point was made in a previous module that when you clear the market, you have to care about forecast. It's about the forecast load, it's about the forecast wind power generation. So this variable is about how much of a share of wind power generation we believe we have to meet our load. Normally, when we look at the impact of different variables on prices, we think first of the hour of the day. The hour of the day represents most likely the demand. You're going to have a low demand in the morning, the demand is going to increase during the day, and then you're going to have the peak demand late afternoon. This should impact the prices consequently. When you take this slice here for zero forecasted wind power penetration, you could say it's the reference case of not having renewable energy generation in the system when clearing the market. So this would be the pattern for the price with this evolution that I just explained, depending on the hour of the day and eventually depending on the demand. What is interesting here is that you increase forecasted wind power penetration in the system through the electricity market clearing. We see two things. First of all, the price lowers steadily. And second, you can see that the pattern of the evolution of the price throughout the day is also flattening. So somehow the effect of wind power generation is taking over and then smoothing these variations in the price. These kind of studies have been then reproduced by many others for different markets, different conditions, different years, and these effects are always observed. I will show you an example afterwards. The regression that was shown was for the average price. So the average price would decrease steadily. Here it was divided by 2 between the case of no wind power penetration forecasted to the case of high forecasted wind power penetration. But it's not just about the average price. The simulation results showed we also have to care about minimum price, maximum price, and maybe all the shape of the distribution of prices. So this is what was done here as an extension of the work in the previous slide. With the same data set, the levels of forecasted wind power penetration were split into different blocks, different categories. So between 0 and 5%, you could say it's almost no wind power penetration forecasted, then increasing to 5 to 10%, 10 to 16, 16, 25, etc., and then 40 to 100, which is forecasted very high, you could say, wind power penetration. The resulting histograms for prices are shown here with the 1, 0 to 5 at the back, and then as you increase forecasting wind power penetration, you go towards the front. We can see a tendency as we go toward the front, so with higher forecasted wind power penetration, all these distributions are shifting to the left. So that's what we explained before. The average price seems to decrease as we increase forecasted wind power penetration. But also we see, if zooming on the tails of the distribution, that the tails are disappearing as we increase the forecasted wind power penetration. If the forecasted wind power penetration is very low, the observed prices are very high, the observed high prices are very high. But if we have very high forecasted wind power penetration, in the tail, so what are the highest prices observed? We actually see that these highest prices observed are not that high. So there is an impact. There's no more high prices in the market. The shape of the distribution is also changing. Here, the tail may be quite fat towards the high prices, but then when we have very high forecasted wind power penetration, the tail is not very fat. So that means there's not a tendency to have higher prices. The prices tend to concentrate in the low area. Finally, we also have these extremely low prices that appear, and eventually you would expect that in a market where you have very high penetration of renewables, wind, solar, wave and others, you would tend towards zero prices or negative prices depending on the regulatory framework most of the time. You may reproduce this kind of studies for other markets, other areas, as I was mentioning. We could find in the literature some analysis, some plots, some regression for different market areas. This one is also for the Nord Pool, DK1, so Western Denmark. This one is for Germany, the EEX market area. And then based on all the data that were collected, one may make a regression between predicted wind power penetration, as we saw before, and the price that were observed in the market. Note that here the prices are in kroner per megawatt hour, and here the prices are in euros per megawatt hour. In both cases, the tendency is the same and support what we said before. For very low wind power penetration that's predicted, we have a wide range of potential prices with some high prices there. And as we increase predicted wind power penetration, there is a tendency that these high prices disappear, and then the price on average is lowering. This was for Denmark, but looking at Germany, you see the same. Looking at Spain, you would see the same. Looking at some areas in the world, you would see the same. The basic mechanic of where renewable energy generation enter the supply curve and the impact on market clearing will always be the same. Eventually, there may be also some impact of regulatory framework, but the basic mechanics should be the same. Here we've only looked at day-ahead market prices, but eventually you could make the same type of analysis to qualitatively and quantitatively assess the impact of renewable power generation on the regulation market prices, the sign in the regulation market, the volumes in the regulation market, etc. Another type of study that can be performed, remember that we have different areas over Europe in the market, and then obviously the weather patterns will vary all over Europe. You may have some wind power generation that is very high in Northern Europe some days, and then some other days it's not so high there, but maybe it's higher in the south of Europe. Same for solar energy. You may have a lot of solar power generation in the south and almost nothing in the north, but then another day, for instance, it's high in the east, southeast part, and not so high on the western part. So all these patterns in renewable power generation over Europe, so spatiotemporal pattern, will have an effect on the flows over the whole European power system and the flows in the market. The flows in the market is about how much energy is transferred from one area to the next, and eventually there could possibly be congestions or not, and the prices will split or there will be high impact on prices overall. A study made by Zunio and co-authors analyzed readily what is the sensitivity of the European power flows on renewable power generation and specifically wind in Germany. You could perform the same study by looking at the impact of wind power generation overall for specific country, solar power generation overall for specific country, etc. All in all, there is a lot of data today that can be used to truly and fundamentally understand the impact of renewables on electricity markets. Thank you for listening. Now I would like to invite you to use the self-assessment quiz to check your understanding.